This is your physics teacher, Owade Sulaiman. We'll be looking at week 5, topic crystal structure. We'll start with crystalline materials. A crystal is a material whose atoms are closely packed together in a repeated regular structure. The structure of a crystal is formed by repeating a small pattern of the crystal called a unit cell. What is a unit cell? A unit cell is the smallest part of the crystal which shows the least space between atoms in closely packed arrangement. There are 3 arrangements that the unit cell of a crystal can take. 1, the body center cube. 2, face center cube. And 3, hexagonal closed pack structure. These arrangements are called space latticed. Then we have the amorphous solid. Amorphous solid is the one whose atoms are not arranged regularly like those in crystals. The difference between the crystalline and amorphous substances. In crystalline, atoms are arranged in a regular pattern to form solid with space lattice. In amorphous, atoms are arranged regularly, therefore they have no definite shape. Number 2, in crystallines, they melt and boil at definite temperature. In amorphous, they do not melt or boil at a definite temperature. In crystalline, examples of crystallines are metal and most salts like sodium chloride, copper sulfate, potassium sulfate, and lead 2 iodide. While in amorphous substance, examples are camphor, glass, and black soot. These are the differences between crystalline and amorphous substances. Cohesion and adhesion. The molecule of the same substance or different substance attract each other. As we all know, cohesion is the force of attraction between molecules of the same substance. For example, the attractive force between molecules of glass, the attractive force between molecules of water, and that between the molecules of mercury and all are all cohesive forces. Adhesion is the force of attraction between molecules of different substances. For example, 1, molecule of paint stick to the molecule of the wall of by adhesion. 2, tissue paper, wick of kerosene or towel soak liquid by adhesion. 3, water wet glass or rises up in a narrow capillary tube by adhesion. 4, gum and paper or glue and wood are held together also by the force of adhesion. We have the diagram of a tube dipped in water and mercury and tube containing mercury. If we look at the 2 diagrams, we can see that the meniscus of water curves outward. The meniscus curves outwards, while in mercury it curves inward. Mercury curves inward, and that explains that will be used to explain cohesion and adhesion better. Now, why water wet glass and mercury does not? Water wet glass, because its cohesive force or cohesion between water molecule is weaker than the adhesion between water and glass, while the cohesion between mercury molecule is stronger than the adhesion between mercury and glass. Capillarity or capillary action. Capillarity or capillary action is the rising up or falling down of a liquid in a narrow capillary tube. As we have explained earlier, we have the test tube containing water and another test tube containing mercury. You can see a rise in the level of water in the test tube, and we can see a fall in the level of mercury in the test tube, and this explains better the capillary action. Water capillarity. Water is one of the liquid which rises up in a capillary tube above the level of water in the bowl, as shown above. Liquids like water which rises up in capillary tube always form meniscus, which is concave. But the ear to the ear, but convex to its own liquid part. It's concave to the ear and convex to its own liquid part. It's concave to the ear and convex to its own liquid part. You can see that from the diagram. The smaller the wideness of the tube, the higher the liquid rises in it. Meniscus is the surface level of the liquid in the container. This rising up of water in the capillary glass tube is caused by adhesion of water to the glass, which is stronger than the cohesion between the water molecules. The water stops rising when this adhesion is equal to the water cohesion. Mercury capillarity. If the same capillary glass tube are put in the same bowl of mercury as shown, the level of mercury falls or it's depressed in the capillary tube. Liquid like mercury which fall in the capillary tube always form meniscus, which is convex to the ear, but concave to its part, to its liquid part. The smaller the wideness of the tube, the more the liquid fall in it. This falling of mercury in a capillary tube is caused by cohesion of mercury, which is stronger than the adhesion between mercury and glass. The falling down or depression stops, the cohesion is balanced by adhesion between mercury and glass. You can see the diagram. So that the level of water rises in the bowl, while the level of mercury depressed. Level of mercury depressed. Angle of contact. The angle of contact is the angle measured inside the liquid between the tangents drawn on the liquid meniscus and vertical wall of its container at the point of contact. Characteristics of liquid with angle of contact less than 90 degrees. Such liquid wet the surface of its container. They form meniscus that is concave to air. They rise up in capillary tube. Such a liquid like water has its cohesive force weaker than the adhesive between it and its container. We have the diagram that talks about the liquid with and it's form an angle less than 90 degrees to the wall of the container. Characteristics of liquid with angle of contact greater than 90 degrees. They do not wet the surface of the glass. They form meniscus, that is convex to the air. They fall or depress in capillary tube. The cohesion of such liquid is greater than the adhesion. Effect of capillary action. The soaking of a liquid by blotting paper, tissue papers, and towels, and osmosis are all due to capillarity. Rising up of liquid in porous substances like soil, and rise up of kerosene up the wick of lamp and stove are also due to capillarity. Assalamu alaikum wa rahmatullahi wa barakatuh. That's the end of the class.